Okay, we in the previous video we considered the simplest possible example of coin toss, and from that example, we are going to define some basic elements to define the probability. First, experiment. Intuitive experiment is a process that generates the random outcome. Random outcome is coming generated from an experiment. So if you think about a different experiment, it is the probability will be different, right? So it is important to fix the experiment we are concerning. And second, an outcome is a result from an experiment, right? It's an outcome, it's obvious. And sample space, so actually the experiment and outcome are kind of definition from the dictionary. But sample space is a statistical term. Sample space is simply the set of space of all possible outcomes. So in the coin toss, the only two possible outcomes are head and tail. So the sample space is head and tail. The reason why we define the sample space is because we cannot define probability outside the sample space, right? The the probability it for the probability to be well defined, it must be attached to something in the sample space, right? So it's important to restrict the sample space where where we are talking about. Examples in other cases, so of course the sample space changes when you think about a different experiment. For example, if you roll a dice, then the sample space is 1, 2, 3, 4, 5, 6, right? Of course. And think about another random experiment, like inspect a part. So you are, say, quality control manager of a firm, manufacturing firm, and you are inspecting the manufactured products. And then you inspect one random part, and then the outcome is either defective, you find a defect, or not. So the outcome can be written in this way. And if you play a game, the outcome may be win or lose. It depends on the case, but depends on the rule. But there may be a tie. So win, lose, tie are three different possible outcomes from a game. And customer survey. In a customer survey, the outcome can be satisfied or not. Or if it depends on the scale of the question. Like if the answer is up to say 5-star scale from 1 star to 5 stars, then there can be 5 different outcomes. So also the survey example, it depends on the possible answers. What is the possible answer? And if in a household income survey, the possible outcome is any number. I can say like, so I'm asking to a random person, what is your household income last year? Then the answer could be zero, or like say 10,000, or it could be billion. So any number is possible. Right? Some numbers are too large so that it's unlikely, but in theory, in theory, every number, positive number, is possible. So anyhow, the point here is we have sample spaces defined by the experiment. So when you have experiment, it defines the sample space. And then now we can think about the probability. So probability is defined in this way. When an experiment is repeated many times, probability is the proportion of times that the event occurs. So when we think about probability, it is assigned, it's a probability of an event. So, and it is defined as the proportion of times. For example, if you repeat an experiment 100 times and you observe some event 10 times out of 100, then we say probability is 10%, 0.1. So probability is based on the repetition of the experiment. And data, so from the same structure, we can define the data. The data is the observed outcomes from repeated experiments. So when you repeat the experiment, you observe outcomes head, tail, 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 head. They become data. So just record the outcomes. That's the data. And the sample size, we say the sample size is the number of repetitions, usually denoted as n. So sample size is the size of the data. If you repeat many times, like 100 times, then the sample size is 100. If you repeat the experiment for million times, then the sample size is 1,000,000. So sample size is the number of repetitions of the experiment. And also, this is the size of the data. So this is very, very important in statistical analysis because it determines how good your data is and it determines the accuracy of your analysis. Of course, the larger, the better. So, simply speaking, if the sample size is unlimited, you can do everything, almost everything in statistics. So the statistics, the main problem of the statistics is the lack of sufficient samples. So we cannot observe enough data. So we need statistics. That's the most a simple motivation for statistics. Anyhow, what I wanted to say here is using the probability structure, we can connect the relationship between probability and data. Now you see how we can understand data and how we can understand probability. So, of course, they are closely related. And here is an example. Think about coin toss, and I did it on my computer. I can do anything on my computer. I generated random numbers, and I did the random experiment on my own computer. So I calculated probability of head. So when I toss one coin, it's either 100% or 0%. So the first outcome is head. So then the probability of head at sample size 1 is 100%. I toss one coin, I see head, so its probability is 100%. But the second outcome was tail, so the probability becomes 50%. And the third one was head again, like so. It moves around like this. As you see, it fluctuates a lot when the sample size is small. But clearly the fluctuation goes away, the noise vanishes, and in the end, it approaches to 50%. So the more you repeat the experiment, the probability will approach to the true probability, because the probability is defined this way. Probability is defined as the proportion of times when you repeat many times. So in theory, the many times means an infinite number of times, which is not possible in practice, but in theory, we can think about that as a limit. So this shows why we need a large sample size. As the sample size increases, the probability you observe from the outcomes will be close to the true probability. So here, I will introduce a very important concept. it's about population and sample. So they are purely statistical terms. So we are going to contrast population and sample in later on. So population is the theoretical object, the collection of all items of interest. So collection of everything you wanna see. On the other hand, sample is observed items chosen from the population. So the main difference here is population is everything you are interested in, but sample is just what you observe. So you only observe some part of the population, and that's data. And simply speaking, in our structure, you can understand them this way. The population is observations when the sample size is infinity. So this is everything you want to observe, a collection of all items you would like to see. So if you can repeat the experiment for an infinite number of times, that's the population. That makes a population. Of course, it does not exist. It exists only in theory, but we can think about it. So this is important because this is what defines the true probability. The true probability is calculated from the population. So true probability of head is known only when you can throw infinite number of coins. Otherwise, as you can see, it can be different from 50%, different from the true probability. So population, thinking of the population is very important because that sets up our target. It's the true probability, truth about the random object. So that's what we want to know in the statistical inference. So statistical inference is to infer about the population based on a sample. So if you could repeat the experiment an infinite number of times, then you don't need statistics. You know the truth. But because that is not possible, you observe a finite number of observations, which is the sample or the data. And based on the finite sample, you would like to infer about the infinity, the limit. That is a big picture of what we are going to do in statistics and in this course. Okay, so this is a very very important concept, and I'd like to give you a big picture, and I just want to give you the some important pillars, foundations of statistics. Later on, they are going to be connected much closer to each other, but here it's a more introductory and more, roughly speaking, like intuitive explanation. Okay, I'll continue in the next video. See you later. Bye.